Hello friends, myself Rajendra Mahajan presenting my video on the topic Fourier series for odd function. Watch the video up to end for clear understanding, better understanding of the concepts. Example, find Fourier series, find the Fourier series for the function f of x is equal to x into cos of x multiplied by cos x in the interval minus pi less than x less than pi. Means it is between minus L to L type of function. And therefore, to find the required Fourier series, we have to see the range. Here the given range is minus pi to plus pi. And therefore, we can check the function whether it is even or odd. We can check the function for even or odd. F of x is given as x into cos of x. Here f of x is equals to x into cos of x. And to check even or odd, we have to replace x by minus x on both sides. Therefore, left hand side become f of minus x is equal to minus x into cos of minus x. Cos minus theta is cos theta. Therefore, minus in bracket x into cos x means it is minus of fx. Means same function but with negative sign, and that's why the given function is an odd function. Given function is an odd function in the interval minus pi to plus pi, minus L to plus L, and therefore the value of that capital L is pi. And Fourier series for odd function is given by or obtained by the formula. Formula is f of x is equal to summation of Bn into sine of n pi x divided by L capital, and n changes from 1 to infinity. And we call this as equation number 1, where a0 is 0 and an is also 0 as it is an odd function. And bn is given by, formula is, it is 2 divided by L, integration from 0 to L of f of x multiplied by sine of n pi x divided by L, and its integration with respect to x. Here the value of L is pi, and therefore substituting that value in Bn, we get 2 by pi integral from 0 to pi fx is x cos of x into sine of nx. Pi get cancelled, we get sine of nx, and its integration with respect to x. Taking that 2 inside the integral sign, we have 1 by pi integration from 0 to pi x multiplied by 2 sine of nx into cos of x dx. It is in the form of 2 sine a cos b. Its expansion is by defactorization formula. It is sine a plus b means sine of nx plus x plus sine of a minus b means sine of nx minus x, and its integration with respect to x. Then writing two separate integrals by multiplying x inside the bracket, we have 1 by pi multiplied by integration from 0 to pi of x, first integral, x sine of, we can take x common, means sine of n plus 1 times x, and its integration with respect to x. And second integral becomes integration from 0 to pi x into sine of n minus 1 times x dx. We call it the first one as I1 and second as I2. Therefore, 1 by pi multiplied by I1 plus I2. And we call this equation number 2, where the value of I1, integral, first one is integration from 0 to pi of x into sine of n plus 1 times x, and its integration with respect to x. And as it is the product of two terms of x, we apply integration by generalized part. We have to decide the order in which we have to consider the terms. X is algebraic, therefore first term, and sine is trigonometric, therefore second one. And applying that generalized part formula, we have first term x, integration of sine as minus cos of n plus 1 times x whole divided by n plus 1, coefficient of that x, minus derivative of x is 1. Next integration of cos is sine with that minus sign, therefore minus sine of n plus 1 times x divided by n plus 1 whole square. Keep that sign as it is, don't multiply at this stage. Then substituting the limit as 0 to pi, upper limit as pi. When we substituted upper limit as pi, that first term becomes minus pi cos of n pi plus pi divided by n plus 1, and minus, and that minus it becomes plus sine of n pi plus pi divided by n plus 1 whole square. And for lower limit, first term becomes 0 and second term sine 0 is 0. Oh, I have written sine 0 divided by n plus 1 whole square. Here I am explaining with step by step. Every step I am explaining in detail. Therefore, prepare it very well. Important example as exam point of view. We know the value of cos pi plus theta and cos pi minus theta. Both values are minus cos theta. And sine of pi plus minus theta as minus plus sine theta. For plus we get minus sine, and for minus we get plus sine. And therefore, the value of I1 as it is pi plus theta, cos pi plus theta is minus cos theta. Therefore, that minus and this minus, it becomes plus cos of n pi whole divided by n plus 1 and the second term is sine n pi plus pi is minus sine theta, means it becomes minus sine of n pi divided by n plus 1 whole square, and for lower limit we have the 0. We know the value of cos n pi, it is minus 1 raised to n whole divided by n plus 1. Sin n pi is 0. Therefore, this is equation number 3. the value of I1. Then similarly we go for I2. It is integration from 0 to pi. Yes, we see the term. It is x into sine of n minus 1 times x, and its integration with respect to x. Again a product, therefore applying generalized part, performing by generalized part. First term is x, second term as sine of n minus 1 times x. Terms alternately positive negative. Therefore, first term x, integration of sine as minus cos n minus 1 times x whole divided by n minus 1 minus derivative of x is 1. Next integration of cos is sine, but with that minus sign. Therefore, minus sine of n minus 1 times x and whole divided by n minus 1 whole square. Next derivative 0, we stop here, and limit from 0 to pi. Substituting the upper and lower limit. For upper limit we have minus pi cos of n pi minus pi upon n minus 1 minus minus plus sine of n pi minus pi upon n minus 1 whole square. And for lower limit, x is 0, sine 0 is 0. Therefore, both the values are 0. Then that cos n pi minus pi we can write by taking minus n common. And cos minus theta is cos theta. Therefore, it becomes cos of pi minus n pi upon n minus 1, and sine minus theta is minus sine theta. Therefore, minus sine of pi minus n pi divided by n minus 1 whole square. Be very, very careful while performing this step. Be careful about the sign. And cos pi minus theta is minus cos theta. Therefore, that minus and this minus, it become plus pi into cos of n pi divided by n minus 1 sin n pi as minus, and that previous minus, it become plus sin n pi divided by n minus 1 whole square. Substituting the value of n pi, cos of n pi, it is minus 1 raised to n divided by n minus 1. Sin n pi is 0. Therefore, that term becomes 0. Equation number 4th. Here, this term is plus pi. Check that equation number 4th. I1 is pi into minus 1 raised to n whole divided by n plus 1, and plus I2. I2 is again pi into minus 1 raised to n whole, it is not minus sign, it is with plus sign, and n minus 1. Therefore, from these two terms, I can take pi into minus 1 raised to n common, whole divided by pi. Remaining terms, cross multiplying it, we get n minus 1 plus n plus 1 a small correction. And divide by n square minus 1. N plus n we get 2n. Therefore, here is that correction plus, here also plus, and therefore n plus n we get 2n into minus 1 raised to n whole divided by pi into n square minus 1. And due to that term of n square minus 1, we have to impose condition n should not be equals to 1. Otherwise, it becomes meaningless or infinity. And therefore, we have to calculate the value of that b1 separately using this step. We call this equation number A, capital A. Put n is equals to 1 in this step. We get the value of b1 as 1 by pi integration from 0 to pi 2x into 2 sin x into cos x. 2 sin theta cos theta is nothing but sin 2 theta, and therefore 1 by pi integration from 0 to pi x multiplied by sin of 2x, and then its integration with respect to x. Again, as it is a product of two terms of x, we have to integrate it by generalized part. X must be the first and sin 2x must be the second term. Therefore, for this chapter of Fourier series, integration by generalized part is very, very important technique for the evaluation of the integral. First term x, integration of sin is minus cos 2x whole divided by 2 minus derivative of x is 1. Next integration is minus sin 2x divided by 2 into 2, we get 4. Limit from 0 to pi. 1 by pi minus pi cos 2 pi upon 2 plus sin 2 pi upon 4. These two values for upper limit minus lower limit. X is 0, 0, sin 0 is 0. Therefore, both that terms are 0. 1 by pi, value of cos 2 pi is 1. Therefore, minus pi by 2 into 1. Sin 2 pi is 0. Pi get cancelled. We get that value as minus 1 by 2. Then substituting all these values in Fourier series result number 1. Put all this in equation 1. We get f of x as x cos x. We can substitute the value of f of x as x cos x. Though I have not written here, write the value of f of x as x into cos x. First term is b1 sin f x. Value of b1 is minus 1 by 2 into sin x. And then for remaining values from 2 to infinity, value of bn, it is 2n minus 1 raised to n whole divided by n square minus 1 into sin of nx. N square minus 1 whole multiplied by sin of nx as a required Fourier series of that odd function. This is the required Fourier series. Therefore, every step I have explained in detail. Therefore, prepare example very well. Please like my video, share it, as well as subscribe to my channel. And to receive the notification for such type of new videos, please press the bell icon. Thank you. Thanks for watching.